Okay, so wrapping up wrapping up chapter 5. This is the last I have to talk about chapter 5, and this is not going to build on the last few things. This is just naming again. We're going to do naming. We're going to name covalent compounds or molecular compounds. We're only naming binary molecular compounds. So what does binary mean? Binary means that it only has 2 elements. We're not talking about how many atoms it has. So this is binary, this is binary, this is binary, meaning there's just 2 elements. So it's going to make it a lot simpler. We're not going to name really complex covalent compounds like, C6H12O6. We're not going to do that. We're just going to name simple covalent compounds, binary ones. Now, what's really important to understand is that these are named completely differently than ionic compounds. So, hopefully you have ionic compounds down in your head. You need to make sure you build a little partition in your brain and make sure that you don't let the two rules, the sets of rules for naming, bleed over onto each other. Because I can't tell you how many times I start seeing people trying to name ionic compounds like molecular compounds. It's really easy to name molecular compounds, so it's tempting to do it all the time. So before we move on, I'm going to say you've got to be able to tell the difference between molecular and ionic compounds. So remember, molecular compounds, especially considering the fact that I'm only going to give you binary molecular compounds, the molecular compounds are always only going to be 2 elements, and they're going to be non-metals, 2 non-metals. If you see a metal, or you see NH4 at the beginning of the formula, that's an ionic compound. You have to use the ionic compound namings. Remember, name the cation, name the anion. That's it. Covalent compounds are a little bit different. Imagine N2F5. I just made that up. It might not even be possible. I don't really care. I'm going to name this. They're very simple to name. I'm going to name them. It's going to seem similar to ionic compounds at first. I'm going to name it nitrogen fluoride. I'm always going to change the second one. I'm going to change the second one to have the "ide" be the ending. So just whichever one is second, and you just name them in order. Fun fact, interesting thing. These are actually put in order of increasing electronegativities. So that's why they're in the order they're in. So nitrogen comes before fluorine because nitrogen is less electronegative than fluorine. That's the order we put them in the structures, or in the names. So, however, this is good, but there's a problem. This would also be nitrogen fluoride. So would this. Right? So this causes a problem. A problem that doesn't exist for ionic compounds, because ionic compounds only can combine in certain ratios, whereas molecular compounds, since they're making these complicated structures of covalent bonding, they can bind in a lot more different ratios. So this time we actually do have to use a Greek prefix to indicate how many there are. So here are the Greek prefixes. They start off mono, di, and after that, they're literally just shape names. The shape prefixes, because they're the same Greek prefixes from where the shape names came from. Tri is in triangle. Tetra is in tetragon. Penta is in pentagon. Hexa, hepta, octa, nona, deca. So you need to know these so that you can use the proper one. So going back to that example I had, N2F5, I would call this dinitrogen pentafluoride. And this one would be mononitrogen trifluoride. Except, okay, there's one little quirk. There's 2 little quirks of spelling and rules that we use. You don't put mono in front of the first element, if ever. You never, if if there's just one in the first element, you just say the name of the element. You just don't put a prefix. But you would use it for the second one. So if I had, let's think of, I'm just trying to think of something that actually works. Yeah, let's do something like, this is totally impossible, but I'm just going to try it. This would be dinitrogen monofluoride. So you will use mono on the second element only, never on the first. The other thing has to do with just a spelling quirk with oxygen. So there's two important ones. There's two ones we might talk about. CO2, that's where carbon dioxide, the name comes from, carbon dioxide. CO is carbon monoxide. Notice something about the spelling. I dropped an O. It's not. I didn't put monooxide. I put monoxide. I dropped the O. If the prefix has an O or an A, and it's going in front of oxygen, you drop the letter from the prefix. So N2O5 is dinitrogen. I'm writing very quickly. Dinitrogen nope, not penta, pentoxide. Right? So you just do it that way. Okay? Dinitrogen monoxide, and there's my little note. So, very simply, this first one is going to be nitrogen monoxide. Second one will be sulfur difluoride. This will be phosphorus trichloride. This will be silicon dioxide. And finally, diphosphorus pentoxide. And that's it. That's all there is to naming covalent compounds. As I said, be very careful in making sure that you identify which you're dealing with. I can't tell you how many times I've had students accidentally revert back to using these prefixes when looking at ionic compounds. Happens many times a quarter. So if you give me disodium, wrong, incorrect. You should not be using these prefixes in front of anything in the ionic compounds. Like I said, I cannot tell you how many times I get people doing this. Make sure you're very clear on this. Covalent compounds use these prefixes. Ionic compounds don't. Ionic compounds, you just name the cation, name the anion, that's it. Covalent compounds, you have to use the prefixes to say how many there are. Okay? That's all for chapter